Let's now move on to properties of certain special triangles, and let's start with an isosceles triangle. So what are the properties that we need to understand for an isosceles triangle? The first property is that in an isosceles triangle you will have two sides as equal and the angles opposite to these equal sides are equal. From this common vertex A, which means the vertex which is common to the two equal sides, when we draw the median, that median is also equal to the altitude, that is also equal to the angle bisector, and automatically that is also the perpendicular bisector. From the other two vertices, when we draw the medians, then we would find that these other two medians, which are BE and CF, they would be equal. Similarly, from these other two vertices, if we draw the altitudes, then we would find, if we label them as M and N, BM is equal to CN, and hence what is very important here is that from the common vertex, the vertex common to the equal sides, the median, altitude, all these lines that we had studied are the same, but from the other two vertices, medians drawn to the two equal sides are equal and altitudes drawn to the two equal sides are also equal. This is what we can definitely say in terms of the lengths for the medians and the altitudes. These are the properties for an isosceles triangle. Let's move on to an equilateral triangle. So what are the properties with respect to an equilateral triangle? First of all, by definition, all the three sides of the equilateral triangle would be equal and all the three angles of the equilateral triangle would be equal to 60 degrees. In an equilateral triangle, when we draw the median, that median is always the altitude and the angle bisector and the perpendicular bisector, and that is true for all the medians and all the altitudes and all the perpendicular bisectors and all the angle bisectors. Hence, we have this common point for the centroid, the orthocenter, the incenter and the circumcenter. When we look at the height in an equilateral triangle, which is nothing but the length of the altitude, then the formula for the height is √3 upon 2 times the length of the side. Very useful formula. Height in an equilateral triangle is √3 by 2 into the side. Now, if you want to find the length of the circumradius, which is also denoted by capital R. Remember, circumradius was used to draw the circumcircle. Now, in an equilateral triangle, since the centroid is the same as the circumcenter, we know that this point, which is the centroid and the circumcenter, divides AD in the ratio 2:1. And hence, if we say that GA is actually the circumradius, then it would be nothing but 2/3 of the height, and hence the formula for circumradius is 2/3 of the height. And since the height is actually √3 by 2 of the side, this would be nothing but side divided by √3. So when we look at the formula for circumradius in an equilateral triangle, it would be 2/3 of the height, which is nothing but side upon √3, sorry. And now finally, if we look at a formula for in radius, we can figure out that this part is actually the in radius, which is also denoted by small r. And if the circumradius was 2/3 of the height, then the in radius would be 1/3 of the height, which would be nothing but side upon 2 root 3. So the formula, important formula in an equilateral triangle, height is root 3 by 2 of the side, circumradius is 2/3 of the height, which is side by root 3, in radius is 1/3 of the height, which is nothing but side by 2 root 3. Now another very important aspect of an equilateral triangle. Suppose you are told that the perimeter of a triangle, remember perimeter is sum of all the sides, is equal to 12 centimeters. It is possible to have different kinds of triangles with the perimeter being 12. You can have an isosceles triangle for perimeter 12, you can have a scalene triangle for perimeter 12, you can have a right angle triangle, and similarly an equilateral triangle. So out of all the triangles that can be formed for a given perimeter, which triangle will always have the maximum area? It will be that triangle which has equal sides, and hence it will be an equilateral triangle. So of all the triangles that can be formed for the same perimeter, equilateral triangle will always be the triangle which has the maximum area. So these are the properties for an equilateral triangle. We now look at a right angle triangle. A right angle triangle is a triangle where one angle is 90 degrees. Suppose we look at triangle ABC where angle B is 90 degrees. And if we label these sides as small a, small b and small c, then side opposite to the 90 degree angle, which in this case is AC, is called as the hypotenuse, which will be the largest side of the triangle. In a right angle triangle, we also know of something called as Pythagoras theorem, and Pythagoras theorem states that square of the hypotenuse is equal to sum of the squares of the other two sides. So for this triangle we have b square is equal to a square plus c square. This is Pythagoras theorem. And based on Pythagoras theorem, we have what are known as Pythagorean triplets. Now if we know the values that can form a triplet, then when we are solving problems it becomes very handy because it saves a lot of time of calculation. If a couple of values are given and if we know the triplet, then we automatically fit in the third value and straight away move on with the problem. So if you want to save time in solving problems involving right angle triangles, it helps if we know certain standard triplets. Now let's look at certain standard triplets and we will break them up into two parts. Triplets starting with odd numbers and triplets starting with even numbers. So for example, 3, 4, 5 is a triplet which starts with an odd number 3. Now if you want to arrive at a formula, whenever you have a number which is an odd number and you want to understand what can be a possible triplet with respect to that number, it's a very simple concept. If we say that this number is n, then we would just find the square of n. So with this example, if n was 3, we square it and we get 9, and now we want to split up 9 into two parts which are consecutive numbers, which means 9 would be written as 4 plus 5. So we want to write down n square as sum of two consecutive numbers, and those two numbers would form part of the triplet. Let's take up another example. If we want to start with 5, square of 5 would be 25, and if we were to write 25 as the sum of two consecutive numbers, those numbers would be 12 and 13, and hence we know 5, 12, 13 is a triplet. This is how we can actually arrive at all possible triplets starting with odd numbers. Let's see something similar for triplets starting with even numbers. So let's say we want to write down a triplet starting with 8. Now if this is n, then our next step would be to square n and divide it by 4. So if we were to start with 8 as n, square of that is 64. When you divide it by 4, you get 16, and the other two values in the triplet will be, with respect to 16, the previous number and the next number, which means 15 and 17. So this is how we arrive at a triplet starting with an even number. Now an important point to note is that if we know 3, 4, 5 is a triplet, then any common multiple of a triplet. So for example, if I multiply all the values by 2, I would get 6, 8, 10, which will also be a triplet. So a common multiple of a triplet will always be a triplet. And just to check up this rule once again, for starting with an even number 6, square of 6 is 36, divided by 4 is 9, previous and next number would mean 8 and 10, which also happens to be a common multiple of 3, 4, 5. Knowing triplets is really very useful in problems because it saves a lot of time when we are solving problems. A few triplets would be 3, 4, 5. You have 5, 12, 13. We also have 7, 24, 25 as a triplet. 8, 15, 17 is a triplet. 9, 40, 41 is a triplet, and the list can go on, and we can actually generate this list using these two rules that we have looked at. Let's look at two more properties with respect to a right angle triangle. Now if we draw the median from B, which was the right vertex at which there is a right angle, then this median is actually equal to half of the hypotenuse, which means as a formula we would have BD is equal to half of AC. Median to the hypotenuse is half of the hypotenuse. So we will notice that BD is actually equal to AD, which is equal to DC, which basically means that this point D is equidistant from the three vertices of the triangle, and hence D would be nothing but the circumcenter, and hence BD would be nothing but the circumradius. So median to the hypotenuse is actually the circumradius, and which is nothing but half of the hypotenuse. Instead of the median, if we draw the altitude to the hypotenuse. So if BE is perpendicular to AC, then with respect to altitude to the hypotenuse, we have an important property, which is BE square is equal to AE into EC, which basically means that square of the altitude is equal to product of the two parts into which the hypotenuse is divided. AC gets divided into AE and EC, and BE square is equal to AE into EC. Extremely useful properties for right angle triangles, and especially triplets. If we know them, we save a lot of time. Having seen right angle triangles, let's look at a few special types of right angle triangles. We're going to consider two types here. First, we're going to consider a 30, 60, 90 triangle, which basically refers to the measures of the angles of the triangle. So if we look at a triangle which is a right angle triangle ABC, right angled at B, and if we say that angle A is 60 degrees and angle C is 30 degrees, and once again if we label the three sides as small a, small b and small c, then with respect to 30, 60, 90 triangle, there are properties which say that side opposite 30 degrees is actually equal to half of the hypotenuse, side opposite 60 degrees is equal to root 3 by 2 into the hypotenuse, and if we club them together, we would also get side opposite 60 degrees is root 3 times the side opposite 30 degrees. So these are the three formulae with respect to 30, 60, 90 which will be used very often in problems. Let's look at another special type of a right angle triangle, which now is 45-45-90 triangle, once again referring to the measures of the three angles. But now that these two angles which are other than the right angle are equal, this is also called as an isosceles right angle triangle, because these two perpendicular sides would now be equal. So this triangle ABC, where angle B is 90 and A and C are 45 each, would also be referred to as an isosceles right angle triangle. Now if these two equal sides are referred to as A, then the hypotenuse of an isosceles right angle triangle would always be √2 times the length of the equal sides. So we can look at this formula in two different ways, which is, if the equal sides are given, then the hypotenuse is √2 times of the equal side, or if the hypotenuse is given, then the equal sides would be hypotenuse divided by √2. So this is an isosceles right angle triangle, and again a lot of time gets saved when we know these formulae for special right angle triangles.